Now let's solve this problem in Java. So whatever the algorithm that we have deduced here in counting bits in our previous video, we will implement the same in Java and submit in LeetCode and see whether our algorithm is correct or not. So I will exactly take the same method name as given here. Okay. Let's check for any base condition if there. So n can be 0 as well. So if n is equal to 0, like this condition, then we have to simply return an array with only 0. So let's do this for this edge case. If n equals 0, then we have to simply return an integer array as 0, right? Now let's create our dp of n starting from 0 to n, which is n plus 1. We're taking n plus 1 because as given in this, we have to calculate for n is equal to 2, we have to return n plus 1 number of elements in the array. For 5, it was number of elements was 6. The base condition is 0, right? So this is what we have just done, n plus 1. Now we need to start from offset is equal to 1, which is actually 2 to the power 0, right? As we discussed. We start with, 2 to the power 0, because for 0 it doesn't make sense. So it would start from 1 to the power 0. And then we will use this formula to change whenever the offset is about, it should be changed. When it's the 2 to the power 1 is 2. So only in this 2, 4, and 8, which is the power of 2 to the power 1, to the power 2, to the power 8, only in these 3 conditions we are changing the offset as the formula that we reduced here. So let's start with I will use for I loop for int I, for I is equal to 1, because 0 we have already calculated. Should be n plus 1. So just use the same formula. Just copy this. Okay. And then we know that for each dpi, it's 1 plus dp of I minus offset. One plus dp of I, which is the number itself, minus offset. And offset we already calculated here if it needs to be updated. And that's it, guys. We just need to return this dp. This is the whole solution. Now let's run it for the cases given here, whether it's correct or not. Okay, so instead of using the system out, because we are returning an array, so let's better use arrays for stream, and then I will use count bits of say 5, or maybe just say, maybe you can choose anything. Let's start with 5 first, so that it exactly matches with here. So we should be expecting this output, right? And once I return this array here, then let's better pretty print this for each. The number, I use a lambda expression here. System, I want to put in the same line. That's why I will use printf, and I will use %d and with the space, and now that's it. Well, there's a small bug here. I copied exactly same from DP's this offer offset, but here we should not be n, it should have been I, because we are calculating from I. So it should be like this. So again, let's run this. Yeah, so here we got this output for count bits for 5. Let's see if it exactly matches with this in lead code. So 0, 1, 1, 2, 1, 2, 0, 1, 1, 2, 1, 2. It's working fine for the example given here. Now let's copy this code and submit in lead code. Maybe some space here. Submit. So it works well. So this is the final solution for counting bits. Let's quickly calculate the time and space complexity. So we are only using one for loop. So the time complexity would be O of n. And we are maintaining only one dimensional array, dp. So the space complexity would be also O of n. So guys, this was all about the counting bits problem. In the next video, we will solve the 15th problem of our tutorial series on dynamic programming, which is matrix chain multiplication. This is again a very, very popular problem, which is also found in the most common algorithm textbook, and we will solve it in Coding Ninjas. So see you all in the next video.